all this, even other analysis also there. We'll go into this topic only. This in-place analysis, everybody knows we have to check the structure. Our structure should be stable. We have to make sure that our member sizes, everything is sufficient for the. So here again we have to design our pile penetration. How much we need to penetrate? What is the diameter of pile? So all this we can finalize after this in-place analysis. So we need to consider the water depth and proper weight. Weight control report is must for this offshore platform. And environmental condition, wave, wind, everything. And proper soil data. Even if you are going for 100-meter piling, we need the minimum borehole depth up to the 100-meter depth. And water depth, marine growth at the location. Because marine growth will attract more wave forces. And what is the water condition and environmental condition there, whether it is the more corrodable zone. Then we have to choose the steel, and we may need to put higher thickness steel on the topmost wave placement area. And you can see this, we have to make sure that dynamic response analysis, we have to make sure that our structural natural frequency is away from the wave frequency. And this is a typical mode shift. And seismic analysis. So we used to do part 2, strength level earthquake and ductility level earthquake. When we no need to design our structure for the rare and then earthquake, which may not come, which may come during 1,000 years of occurrence. We no need to design the structure for that. Okay, yes, we can design, but it is again the clock. It will not be the economical structure. We need to design for the strength level earthquake. We are designing our structure for some close to 100 years of event, and for that case, structure should be elastic. Elastic in the sense it should not the stress should not go into the elastic region. But for the rare index, we can allow our structure can fail, but it should not collapse immediately. People should escape. So these are the guidelines given in APA code. So you can see here even our SLE, strength level earthquake, oscillation is very less, something like less than or equal to 0.5 G. We may not go for earthquake itself because we already have designed our structure for lateral loads like wave, wind and all. But if it is more than 0.05 G, we need to go for specific earthquake. So guidelines are there in codes, we can follow. But we need to follow some typical detailing arrangement. We should not go for K braces and all because it is not good for the seismic. So this is a typical arrangement, what to do, what not we do. Or if you are going for the earthquake region, we should not go for K braces. And so this is the guidelines we used to follow for earthquake design. Even we are using ISO code, IS 1893 for onshore. That the basic and concept, everything is the same, even if it is for APR. So the fatigue. Fatigue, we need to fix whether we need to go for details fatigue or whether simplified is enough or not. We have to calculate our natural frequency of structure. If our period is more than 3 seconds, definitely we need to go for spectral fatigue because the probability of fatigue failure is more. So we need to calculate the spectrum. We will get all the wave, environmental data, everything. All meteorological data we can get it. So anyway, without the data we can't design. So our thing is we have the SN curve. SN curve in a sense like number of cycles to fail with respect to the stress range will be there. It's not stress range. Stress range in the sense the positive and how much it can come. What is the bandwidth of the stress? It can go to the negative and it can go to positive. The stress range will define in how many cycles it will fail. This steel is from API. This curve come from various experience. Like maybe experimental method they define this curve. So you can see here number of cycle to failure is more if your stress range is less. You have to calculate what is the actual number of occurrence because we have all the data, all the environmental data, and what is the waypoint period, everything will be there. What is the number of occurrence for 1 year we can get. So we can extrapolate that for 25 years or 30 years. From that we can define. So what is the our operating life of our structure? And this is pre-service analysis. So we are building our structure again yard. Then we have to load it out. So we can place on some top of trolley, and the trolley can. So here we have to control the trolley movement. It should be hydraulically connected. There is a possibility it can topple. All this we have to study here. Here, thing is, our support boundary conditions are entirely different. It's not like normal in place, but we have to simulate here our boundary condition and loading, and we have to make sure that our structure is safe for this condition also. Not possible load out arrangement, load out conditions are it can be lifted and load out if it is lightweight, or if it is very heavy weight, we can use we can skid it. We can put some rails below, and we can pull the rails, and we can do for skidder load out and trailer load out. So you can see this image. This is the typical trailer load out. This is the typical jacket, how we are loading out into the barge. So we have to see the various scenarios. The barge can go up and down. So our support condition will change. If its barge is going up from this figure, that outermost, bottommost portion will not get up. You have to design your structure for that. Otherwise, you will end up with some wrong result. This is a typical picture for skidder load out. When the weight is heavy with a pipe rack, we are there. People are skidding there. You can see some rails are placed below. This is skidder load. And this is a typical trailer load out scheme. So we are placing some two numbers of trailers here, and the modules will be placed on top. This is a typical trailer load out. You can see this is the various scenarios. What is shown before. This one is just the top side. The Techsurge is loading out. You can see the possibilities during the cycle load out. Even the first stage, you can see everywhere all the locations it is supported. And the second stages, you may not get full support. So you want to design your structure for all the support conditions. Then only it will serve the purpose. As load out, skidder load out image. So that jacket is entering into that barge. So then next one is transportation analysis. Once you load out into the barge, then it has to be transported to the site. So for that, we are doing the transportation analysis. You have to check whether the barge is stable, whether that barge is. We have to check the ballast condition. It should not sink. We have to do some ballasting everything. We have to make sure that barge is stable, and that is barge stability we have to study. Additional, you will feel some motion due to that roll, pitch, arch, station, and all. You will feel some motion. For that, actually, our structure should stay. And even that global integrity of structure we have to verify during the transportation. So transportation, what are the possible transportation methods? If it can be tried out, so we can place the structure on top of barge, and it can be using the tugboat. Tugboat can be self-propelled barge also. You can transport to the site and wet it out. If it is heavy weight, self-top for heavyweight jacket and all, we will barely launch to the water and we will pull it because we may not have sufficient capacity barge. Anyhow, it is again cost. We will get the barge, we may get after 1 year. So everything is we have to plan. If you want to go for the self-tow, our structure should be proper buoyancy should be there. It should not sink. All this we have to study, and we may need to go for some extra support, some key fasteners, All this necessary requirement we can find out after this transportation analysis. This jacket transporting, the jacket is transporting on the body, and this is the top side of the attacker. So you can see some additional supporting number of segments they provided. This is to for the stability purpose. So typical barge arrangement. Just a minute. So this is a balancing scheme. So we need to we may need we will not deballast all the tanks. We may need to deballast some tanks and ballast some tanks so that our part should be stable. So that ballast condition we need to study. We need to do motion analysis to find out the barge stability. It's a typical support arrangement we use to simulate. So and we will find out whether the structure is safe or not. Then only we can produce the drawing for the condition. So you know when transporting on the barge will rotate in all the 60 degrees of freedom is precious, it is possible. So we will consider all the key motion, sway and surge motion, everything we need to consider, and we have to simulate the proper loading for the structure. So this is a typical jacket transportation simulation model. We know that even without software also we can do it. We have to calculate what's the acceleration component, how much load it will act, and if you know the load, then this is normal even for onshore structure or offshore. It's a transportation. Additional, the barge also can bend. We have to consider the deflection of on the barge also. So there is a possibility it can create more stress under the structure. The image for jacket transporting. This jacket they are transporting vertically. Then will lift it using some lift crane and will place into the water. This is maybe shallow water jacket. If it is deeper, we can't place it on the barge like that. This is a deeper jacket they are transporting. Then we have to launch it into the water. If we found sufficient barge capacity, we can lift it. This deck lifting installation photo. This is a bearing. So we need to provide some lifting tool. So this is bearing arrangement. We will provide some shackle and sling so we can lift it. If it is heavy, we can go find a Darnian arrangement like a tubular so that like slings and we can lift it. So this lifting arrangement of jacket. They are lifting horizontally. But everything is dependent. If you have that sufficient barge capacity or not. If you don't have sufficient lifting crane capacity, then we may need to launch the jacket into the water. If we need to go for launch, then we need to make sure that our barge that sufficient buoyancy should be maintained. So this is next one is lifting analysis. So once you transport into the site, you have to lift it and place into the ocean, that's the position. For that we need to do lift analysis. During lifting analysis, even initial computer model will generate model. It may not be close to the real situation. If there will be weight difference, will be there. We may not exactly model the COG position. After weighing our COG will get a different. All these scenarios we need to consider or possibilities of COG variation, possibility of weight variation. All this we need to consider during the lift analysis. When we can go for some with a better frame arrangement or better bar, or you can use even dual frame. All this we have to study before configuring our system. And it's a typical headache. It's not small, it's a very big size. Because our lift weight is 3,000, 4,000 ton and all. Then flotation and upending. So why we need flotation and uppending? If it is heavy jacket, then we can't lift it. We may need to launch, and it has to be float, and it has to come in vertical position. So we have to append it. Then only we can install pile to that. So you can see this jacket is floating. Now we can see there is a lifting crane. So that with the help of the crane we can open it. Or if you don't have sufficient crane capacity, you can control it using the flat. Using controlled pressing, you can we can press the jacket legs such a way that it will come into the vertical position. So this is jacket launching scheme. So we can launch it like that, and with the help of crane we can open it. So because once you launch into the water, you will feel the swing because buoyancy will be in the road. Then and the crane can control. This jacket this is 8 leg jacket. You will open it and it will be positioned. So this you can see that launching image. Then on bottom stability analysis. So once you launch, then once you make it vertical, it should be stable. It should not move, or you can see some stability problem will be there. It should not sink in, it should not slide, or it should not overturn. All this we have to study it. Otherwise, it will not work out. We have to make sure that our structure is stable during on bottom condition also. We can we'll get the soil data, so we can check it whether it is sufficient bearing capacity is there. If it is very poor soil, we need to go for very big mud mat. I'll show the photos. We'll fill full concrete, maybe steel plate at the bottom, so that it will be evenly distributed at the road. And sliding also possible, and overturning also possible. All this you have to estimate, and we have to make sure that our structure is stable. And this is the mud mat. So it's not necessary to put entire full area mud mat for bearing purpose. If you have good soil, you can put for even small mud mat. So next one is pile. After installing this jacket into that position, then we have to install the pile into that through the length. So for that we have to do pile drivability analysis, whether can we able to drive it. That is a major thing here. Do you have the sufficient hammer capacity? If you don't have the sufficient capacity hammer, then we may need to design for lesser penetration. So we need to go for large number of piles. Or if you have bigger hammer, okay. If you have some limitation, then we need to limit the diameter of pile. So all this we have to check during initial stage itself before finally in the jacket car. There is also possible pile rundown and rundown in the sense some in between some soil is weak means while driving itself it can go in. Then you can pull the pile. So pile drivability analysis, you have to consider the self weight of pile will be there, hammer, even wind load, pile driving load, all this will act into the pile. Make sure that our pile is safe for that. You need to provide the sufficient thickness. Anyway, if you provide for higher thickness everywhere, then again it is task how to lift it, how to place it on the top of the jacket, all this you do. So normal pile makeup analysis, you can see there near to the mud line you have higher thickness. So that is for the strength point of view, place point of view. And you have even topmost level also higher thickness you may need because it will create more driving stresses you will feel at the top. Everybody need for single pile, but it may not possible because we may need 100-meter penetration. So we need to do welding in between. We have to feel. We have to install pile piece by piece and we have to weld it. You can see this. They install the first segment and second segment of pile is placed on top and they are welding. So when this weld will take 1 day. When you go offshore, installation time is costly. So we need to avoid that type of welding. We may need one single pipe. This may not possible in all cases. You can see this pipe they are installing to the jacket. So basically they will install all the 4 files one by one, but make sure that it's not overtime. Such a way that you have to place the files properly, and they will do for hammering one by one. So this is just a construction image. We will construct everything onto yacht, then only it will be done for the like, this is the yard code, yard code. This is just jacket lifted installation. So this, I think you saw this image when transporting this jacket of how this is they are lifting and installing. The jacket mud mat for the stability purpose. If it is based on the bearing capacity of soil and based on sliding, overturning, calculation, everything we have to fix how much we need. Do we need full area mud mat or not? Then deck installation. After installing that, after piling, we can install the deck. So even we can go for installation using lifting or maybe float over also possible if it is heavy data. So what you can see here, in this case, jacket is installed, but the top way of bracing is avoided because the barge gets to come in and will balance the damage. The barge will stay in the water. The deck will sit on the top of piling. This for heavyweight models. You can see this float over installation. So next, another is FPS also possible. Here we can take some old ship or even we can construct some tanker, and for that on the top we'll build our all the platforms for the processing. And we can store the oil inside it, and we can unload it using some unloading tank. And FPS so module. Like old personally purchased tank modified to suit for it. You can see like FPSOs are there. What is before is just the typical manual platform, but in this FPSO we can take all the oil in the surrounding area using risers, and because the area is wider, we can process everything here. You can see this image as this is complete our built Exxon Mobil and petrol park. See this 1,500 meter water tank. This is fixed jacket. Even we can take the 400 meter.
Thank you, sir, for sharing the information on offshore pile foundation, in-service analysis, traffic analysis, and transportation analysis. Now I call upon Mr. Pradeep, Professor Civil Aram ISD, to facilitate Mr. Light.
ಸೆಂಟರ್ಲಿ ಅಲ್ಲ.
Now we have a keynote session on applying AI technology in ocean. I invite Ms. Preeti to introduce the keynote speaker, Dr. P. Varalakshmi. Yes, sorry. Now we'll have a session on accelerating AI applications with MATLAB and Simulink. I invite Ms. Preeti to introduce his keynote speaker, Dr. Dev Singh.
Devanand Singh Thiru, PhD, works as a part of education team at MathWorks India Private Limited, Bangalore. In this role, he collaborates with academic institutions for effective utilization of resources in education and research. He is passionate about technologies related to electrification and has extensive experience in the area of modeling electrochemical energy conversion systems. He has an interdisciplinary background with bachelor's degree in physics, followed by MSc PhD degree from the Department of Energy Science and Engineering, IIT Bombay. In the previous roles, he has worked as a postdoctoral fellow in the Department of Energy Technology, Aalborg University, Denmark. We heartily welcome you, sir.
Good afternoon, everyone. Can you hear me clearly?
Yes.
This is a habit mostly from working virtually. It's finally good to see all of you online and good afternoon, everyone. Firstly, thanks to the organizing team from SRM and MTS for giving me this opportunity to be in front of all of you. So myself, as you heard, I am from the education team of MathWorks. And we very closely work with academicians, industries, as well as scientists. So what I am going to cover now is to give you a brief overview about who we are, what we do, and then we are going to see a few use cases. So like previously, we will look at the use cases, and we will also try to see what are the things that made these use cases successful, how they were able to effectively use AI, and while using AI, how they were able to get the things they wanted to do in a very short period of time. So effectively, how they were able to accelerate the pace of their work by using MathWorks tools like MATLAB and Simulink. Okay. So how many of you are already familiar with MATLAB and Simulink? Could you just please give me a hands up? So that's pretty good. Many of you I see. How many of you are familiar with using MATLAB and Simulink in the AI discipline? Okay, so this could be shows what is AI in the context of many of the systems or many of the processes that we see nowadays. So MATLAB and Simulink, all of you are familiar, so I'll go into details. So these are specifically platforms. MATLAB is specifically a platform for you to actually get your algorithm built, and Simulink is specifically a very interesting platform that industries use to prototype their dynamic systems, model and prototype, as well as test out their dynamic systems. Who are our key industries? So when I talk about energy production, chances are that the energy might be used somewhere in the sea, right? It could be a wind turbine located in an offshore place, or it could be certain energy conversion devices from waves. So like this, we have a footprint across multiple industries. Now looking at a few close cases of application in the marine domain. Anybody knows what these things are? Yeah, so these are specifically this is a tool that is kept in the oceans. So what used to happen previously is that in the US, I think NOAA was doing some studies with respect to studying the reflection from the ocean, And when you see a satellite over a period of time, the satellite actually, the images that it takes, it sort of, the resolution of the image gets affected. So time to time they have to do a calibration. So this sort of optical buoys help in doing the calibration. So in this case, the main challenge is that it has to be very accurate. That is one. And also, there is a problem of also data acquisition. So you have to be able to get the data, as well as you have to make sure that the data adheres to certain standards. So they were able to use the MATLAB instrument control toolbox to actually work with this set of problem, and eventually many of the problems got sorted out by using this toolbox instead of directly going and doing things step by step, right? One more interesting user story I have is from the Cornell bioacoustic scientists. So in oceans, whenever we are putting a sensor, chances are that we might gather a lot of data, right? That is also something that we were hearing from many people. So we have a lot of data, how to make best use of the data. So to make best use of the data, we have to analyze it in one way or the other. So what the scientists said it was that they came up with a high performance computing platform where they were able to use the big data sets which previously they were not able to use. So whenever you are able to use this sort of big data sets, chances are that you might make some or other discovery, right? And in this particular case, what they found was that they were able to understand how human activities were affecting the health of ocean ecosystems. So now, going ahead, and I will now focus a bit more on the AI aspect of things. So when we talk about AI, wherever you go, you will hear these 4 distinct steps: data preparation, AI modeling, simulation and test, and deployment. So the reason companies choose for the so how to label that data and make it useful so that I can train my model. So we have apps. We have apps that can help you do automatic labeling of the data, right? So here you can see, I'm just identifying the car on the road. Chances are that if I have some other sensors also, I'll be able to attach a keyword to the car. And then once I do that, I can actually automate this entire process. So if you look there, once I have identified that, all I can do is that I can automate this process, and for whatever data I have, automatically it is going to label all the images. So it will save a lot of time from manually labeling the images, right? Going to the next part, the AI model. So no matter whether you are building a machine learning model or whether you are building a deep learning model, whether you have a programming background or not, because chances are that many of us are actually engineers, and what we want to do is spend more time engineering or making some fine tuning rather than hard coding everything. So we have a code approach that we say is quite flexible. It's a low code approach where you use apps. If you want, you can use apps, or if you want, you can go with code also. So it's a flexible approach which is there. So there are 3 apps which are there specifically in the area of machine learning. You can use classification. In the deep learning side, there is a deep network designer app, and then there is an experiment manager app. So these apps are something that you can use to very conveniently work with your AI models. So just to give you an example, if you look there, there is a particular app known as Deep Network Designer. So using this, you have a graphical interface where you can actually import different networks. So there are already good pre-made network. If you want, you can import them, or if you want, you can make your own network right here in this canvas. Connect everything together. So it's a drag and drop environment. It's very fast. You can just make your network within seconds, and then you just define the parameters of a network, and then in the very same place, what you can do is that you can sort of look whether the network you have built is accurate or not. You can import the data set for training it. Well, I don't think you can do it this fast. It has been made faster. But obviously, you can actually, if you see, everything is done using without writing a single line of code in this case, right? So you can put in the databases and then you can train it all at one given place. So here I can see the training is being started. So you can view the training progresses, and if you see no improvement, then you just go back and try to see if you can improve your network, or if you can change your network training options. And in many cases, chances are that if you have a very good computation facility at your end, you can use those computation capabilities directly with the help of something known as a parallel computing toolbox. So here we can see once we get good results, we can actually sort of take the train network and then go to the deployment stage, right? Some use cases that we have seen, this is specifically one from research and one from another story that is there. So the first thing, if you see here, this is a case of removing blur and distortion from underwater photography. Right? So we saw in the during the first half that this was one of the key areas many of the presenters are also working in. So this is a story from University of Haifa, where what they were able to do was that when you take a photograph in water, so different wavelengths that come from specific part of the images are attenuated in a different way, right? So they sort of created a computer vision algorithm in which they actually measured the attenuation for different colors. And once they were able to measure, they came up with an algorithm which, when you apply to an image taken underwater, will sort of give you the real color, and it will remove the blur also from the image that was taken. And this actually really helps with many of the problems that people are working on, like global warming related changes in coral colors and all. The second is also a very interesting user story where the student community was involved. So if you see here, many parts of the world, what they face, a challenge that they face is that icebergs come into the shipping routes, and they have to be able to identify which one are icebergs and then issue some sort of warning to the shipping industry. So in this case, a couple of companies came together. One of them was, I think, from the Norwegian region. So what they did was that they took all these images. So these are SAR images, synthetic aperture radar images. So these images, using these images, they created a competition for students in the Kaggle community. So all of you, I hope some of you are familiar with Kaggle competitions, right? So a lot of students took part in this competition, and they came up with their own methods, their own deep learning models to identify which one are icebergs. So what this institute was that from the submissions from the students, they actually built one more algorithm which was able to take in the learnings from all these different students and come up with an algorithm that could actually detect icebergs a lot better than the individual algorithms. So this was a very interesting user story where MATLAB was used and the student community was involved in creating solution for the particular industry. Also often, one question we hear in AI is that, is my model accurate? So we have to carry a lot of different studies to determine which is the best model. So we have something known as an experiment manager where you can experiment with the different parameters in your AI model. So you can change the learning rate, you can change the hyperparameter search methods, and then all the results you can look at one place and then compare which hyperparameter is important, what sort of eventual accuracy you are getting, and then you can see all the results in one place, and that helps a lot, right? It saves a lot of time for you if you are able to create this experiment and keep it running. Also, the last step is deployment. So deployment plays a major part when you are building any sort of application. So once you build a model, you can actually deploy into different sort of hardware, be it a CPU, be it a GPU, or be it any FPGA. You do not have to know the specifics of the hardware. MATLAB has coder products that will generate code for that specific hardware. And it will generate code that adheres to certain standards. So nowadays there are certain standards, as we heard from our speakers previously. It will generate code that will adhere to a certain standard. So that's a very important point that is taken care of. And this is why companies like DRAS are actually looking at our workflows. So what they did was that in a very short time, they were able to actually generate a real-time object detection algorithm and then run it in real time. Okay. So if you see here in terms of the results, the data labeling part for the data that they had was automated using MATLAB. So overall development time could be reduced, and also we have GPU coders, so automatically whichever model you are generating, building, you can directly convert it to CUDA code. So they were able to use and deploy this particular algorithm on NVIDIA GPUs, although they had very less experience with GPUs, right? Lastly, to end with, I will say that when you talk about AI nowadays, in industry specifically, AI is part of the entire workflow. It's not that as an engineer you will work on AI in a silo, you have to work with a bigger team. So let's say I have to build an underwater search mission vessel which will identify particular objects on the ocean floor. So in this case, if you look like there has to be some sort of engineering at the system level. So there will be a person who will decide what are the requirements of a vessel like this, right? What are the requirements? Then he will say that, okay, this system must have this components. There must be some autonomy algorithm which will determine how it moves, which path it is going to follow. There will be sensing platform which is going to sense the environment, and then there will be a propulsion part also, right? So when I'm building an application like this, right, there is a system engineering aspect, right? Lots of details I have to look at, what is required and whether I'm going to meet it or not. Then there is a platform part of thing. So I have to choose a system model, I have to decide how I want to test it out and all. And then the autonomous algorithm will be sort of it will be sort of a component of the entire system. So there has to be something with respect to sensing, something with respect to perception. Probably these are the areas where I can fit in my AI part. Right? There is a planning aspect, there is a control aspect. So there are so many different aspects that comes together that has to be integrated when you are building an application like this. Right? So the good thing is that when it comes to MathWorks, we have one single platform where you can do this entire thing. You can build everything from the requirements to the testing, and you can then connect and deploy it. So you see here with respect to whatever I talked about, we have exactly toolboxes that can make your work faster. So it will already have some algorithms and functions that you can directly incorporate in your model. In many cases, we have ready to start examples which you can sort of tinker with. And you can test it out in virtual environments to ensure that whatever results you are looking for is there or not. So if you want to get started and if you want to see this particular application, so I would suggest you can look at a video series. So we have a very good deep dive video series where you go step by step to the different part. If you are a system engineer, probably you will be interested to know how you work with requirements. If you are a person from a domain who is going to build it, so you can actually see how you can import CAD model, connect them together and look how it is going to move through the water, what efficiency you get. And then finally, if there is some need, you can actually optimize the entire system also, right? Even before building it, you can optimize this sort of systems. So with this, I will sort of end the presentation, and if there are any questions, I will be happy to take. Yeah. So just a summary of why MATLAB and Simulink really works for deep learning. Yeah. So that's all from my side. If there are any questions, I'll be happy to take. Yeah, thanks for being here on a Saturday afternoon. I really appreciate all of you being here. Great to have you all.
Thank you, sir, for an informative session on accelerating AI applications with MATLAB and Simulink in marine applications. Now I call upon Dr. Preeta, Professor Tripoli, SRM IST to facilitate Dr. Dev's. Now we'll have a keynote session on applying AI technologies in ocean. I invite Ms. Preeti to introduce the keynote speaker, Dr. P. Varalakshmi.
Dr. P. Varalakshmi, currently working as a professor in Anna University MIT campus. She completed her bachelor degree from Government College of Engineering, Coimbatore, MTech from Pondicherry University, and PhD from Anna University. She is the life member in the Indian Society for Technical Education. She published more than 56 journal articles, 7 book chapters, and 93 conference proceedings. She received various funded projects from DIT, Center for Technology Development and Transfer, Tamil Nadu State Council for Science and Technology. We are happy to welcome you, ma'am.